Welcome to Ask and Learn.
All right, let's get started with some free body diagrams here. So this is the downhill case, um, and we're defining our axes such that the normal force direction upwards is positive y-axis, is positive y, and positive x is uphill. Okay, so um, when the cyclist is coasting down the hill, the force of friction, of course, gravity and normal force acting downwards and upwards as shown here, but when the cyclist is coasting, force of friction is opposing his motion, and so the and so that's the only horizontal force that is acting opposite the direction of travel. When the cyclist is pumping the brakes or and applying a pumping force, let's call that F sub P1, you again have a friction force acting opposite direction of motion. We're going to call this FR1, but there's P1, which is a pumping force from downhill motion, which is acting in the negative x-axis. Okay, so let's get started with Newton's second law resolving forces. In the x direction, when you're coasting, friction force is just equal to horizontal component of gravity, mg sine theta, because there's no net acceleration. He is coasting. When he's pumping, again, you resolve forces in the x direction, but now you have F sub FR1 is equal to FP1 plus mg sine theta, right? And so FP1 is the quantity of interest, the pumping force, which is equal to FFR1 minus mg sine theta. Now, how do we know what FFR1 is? We know that F is proportional to v squared, velocity squared. Therefore, taking a ratio of FR1 to FFR, we take the ratios of the two velocities. So coasting velocity is 12 kilometers per hour. Pumping velocity is 32 kilometers per hour. And so just take the ratio of those, 32 over 12, and you square that because the constant proportionality constant cancels out. So FFR1, therefore, is 64 over 9 times FFR. And what is FFR? It's mg sine theta, as we saw here. So this is 64 over 9. Whoops, let's write it down better. This is 64 over 9 times mg sine theta. So therefore, we have that F sub P1 is mg sine theta, that's the common term, times 64 over 9 minus 1, right? I just replaced FFR1 there. And so this is 55 over 9 times mg sine theta. All right, therefore power, P1, is equal to FP1 times V1, velocity 1, and velocity 1 is of course 32 here, and so this is 55 over 9 times V1 mg sine theta. That's P1. Okay, and we're going to call that equation 1. All right. When you're going uphill, the only difference here, the difference is that force of friction is acting in the negative x-axis now. And so when you're pumping, going uphill, let's use a different color right now, actually. You're going uphill and you're pumping, the force that you're resolving when you're resolving forces in the x direction, you have F P2 is equal, or you have 2 minus FP, excuse me. You have FP2 minus FR2, force of friction in that case, minus mg sine theta. Therefore, FP2 is FR2 plus mg sine theta. Right, and so we need to know what FFR2 is, and again, we use a ratio of friction forces. FFR2 over FFR is just V2, which is something we don't know, over force from here, 12 quantity squared. Therefore, FFR2 is just mg sine theta times V2 over 12 squared. All right. And so now we use the fact that power will be the same in both, for both cases. So P1 will be equal to P2. And so P2 is equal to FP2 V2, right, which is equal to P1. And P1, as we recall, is 55 over 9 times V1 times mg sine theta 1. V1 is 32, by the way. And so FP2 is equal to 55 over 9 times V1 over V2. Actually, you know what? Let's just write down what V1 is. 32 over V2 times mg sine theta 1. From here, we have that FP2 is FFR2 plus mg sine theta. And so this is actually equal to mg sine theta plus FFR2, which is mg sine theta times V2 over 12 quantity squared. All right. So therefore, we have mg sine theta in all the terms. So take that common, mg sine theta times 55 over 9 times 32 over V2 minus 1 minus V2 over 12 quantity squared is equal to 0. So what we're left with is the following equation: V2 cubed plus 12 cubed V2 minus 55 over 9 times 12 squared V1 is equal to 0. Numerically, this is V2 cubed plus 144 V2, whoops, I meant to say 12 squared over here. V2 cubed plus 144 V2 squared, or 144 V2, no squared there, minus 28610 is equal to 0. So you can plug this into your calculator. This is a third order polynomial equation. And the answer comes out to be V2 equals 28.85 kilometers per hour. If you want to convert it to meters per second, go ahead. But as long as we're using the same units throughout, you should be good. And that is it.